is supposed to be is supported by bar joists as shown in the picture here. Each joist is 15 feet long and they are spaced 2.5 feet on center. The floor itself is to be made from lightweight concrete that is 4 inches thick, and we are supposed to neglect the weight of the joist and corrugated metal deck and determine the load that acts along each joist. To solve this problem, you would first need to calculate our dead load and our live load. And if you don't know how to calculate it, go back to my other videos. So let's start with the dead load. To calculate dead load, we need to, first of all, find our minimum dead load from our dead load table. And we can see for our lightweight concrete plane, it's 8 pounds per square foot per inch. All right. So we know that our concrete is going to be 4 inches thick, and we know its dead load weight is 8 pounds per square foot. And solving this, we get 32 pounds per square foot. Okay, so now that's our dead load. And now going to our live load and looking at our minimum live load table, we know that this classroom will be 40 pounds per square foot. So this would be 40 pounds per square foot. And adding these weights together, so our total load would be 32 pounds per square foot plus 40 pounds per square foot. And this comes up to 72 pounds per square foot. Once we have this, now we have to determine whether it's a one-way slab system or two-way slab system. First of all, our length of the beam must be greater than length of the span. So here, the length of the beam is 15 and span is 2.5 feet. So that's good. And our span ratio should be greater than 2 in order to be one-way system. And let's see if it is one-way. 15.25. So 15 divided by 2.5, we get 6. So yes, it is greater than 2. So that means it's a one-way system, one-way slab system. Now with that we know what this system is, we can find its uniform load. So our uniform load for this system would be our total load, which is 72 pounds square foot, times the span between the beams, or joist in this case. That's 2.5 feet. And solving this comes up to 180 pounds per foot. Okay. Now that we have that, we have to find load that's acted on each joist. All right. So let's say this is our joist, and load that would be acting on this joist would be 180 pounds per foot. We can do one more step and we could find the force that would be acting on each joint connection of this joist. So let's do that. In order to solve this, we would need to multiply our uniform load, which is 180 pounds per foot, times length of the joist, which is 15 foot, and this comes up to 180 times 15. This comes up to 2,700 pounds. And we know this is the total load or force. And if we divide it by 2, we would get 1,350 pound, and that would be our solution to load on each connection of this joist. 1,350, 1,350. Like and subscribe for more.